Morning, afternoon, or evening, no matter what time zone you're in, welcome back to Sip and Talk. Whew, hey! Mickey's presentation videos he uploaded for us have been pretty popular lately.
They really have. It pays off that we promote him every episode. It's, a kind of reciprocal concept. He even said managing it counts as a sponsorship. And I said, okay, you can say you sponsored us. This guy is really good at finding reasons.
He is.
And if you don't know what the presentation videos are, they're basically condensed highlights of our single episodes.
Right.
Like an espresso shot. If you haven't seen them, go check them out.
The problem is I feel like my workload is already big enough. I do a lot of the heavy lifting. Okay, fine. You help too, and so does Ethan. Thanks, Ethan.
He's laughing.
That's the master of yeah, who always adds his reactions to our show. He does it on purpose.
Anyway, the capables do more work. We often say, with great power comes great responsibility, right?
I suppose.
Back to the topic. The subject we're discussing this time is super hardcore, but also, incredibly close to everyday life.
Exactly. Last time you said AI always lacks a bit of local flavor, right?
Mm-hmm.
This time we're moving from that flavor all the way to state secrets, global competition, and even the question of your job security.
You nailed the description this time. The core question we're exploring today is, what happens when AI upgrades from being a tool to a national strategy?
Right.
We spent a huge amount of time breaking down Nova4j's mid-training service. The appearance of this service signals that sovereign AI is no longer just theory. It's a strategic commodity nations can pay to purchase.
That's right. Sovereign AI sounds cool, like the domestication of AI.
Yeah.
But behind it is the extreme anxiety of various countries over data privacy and technological autonomy under the shadow of the U.S.-China tech war. It's like buying pre-cooked food to finish at home, ensuring the core ingredients weren't snooped on.
That's a great analogy. We also did a deep analysis of the concrete implementation of this AI wave in China, the rise of the Chinese robot army. This allows China, with the dual advantages of a labor shortage and strong mechatronics integration, to rapidly advance robot automation.
But the contradiction here is what's truly thought-provoking. Ostensibly, the robots are coming to fill gaps, but in reality, their impact on low-skilled labor is replacement.
A huge difference.
Our final thought experiment throws out a sharp question. Should the world worry about China's robots being too strong, or should the Chinese people themselves worry about the resulting unemployment being exacerbated?
To summarize, today's topic is about AI power and distribution. Sovereign AI is the competition among nations to control AI power. Robot technology, meanwhile, is restructuring the allocation of productivity gains and social costs.
Right.
These two phenomena together point to a core trend in AI's future. The technology will become further politicized and nationalized, profoundly disrupting the global labor structure.
So, Sip and Talkers, this is not just a conversation about technology, but a deep exploration of your data security, your nation's future, and your next job. Let's dive into today's exciting content.
From Nova4j and sovereign AI to the robot paradox, and now connecting it to physical AI, the logic flow is perfect.
Hey, our show is synonymous with logic.
Let's get into today's topic, AI sovereignty and the robot dilemma.
Okay, so let's unpack this term, Nova4j. It sounds, intensely technical, but what you're saying is it's really a strategic move by AWS.
It's a huge strategic move. It's designed to solve the two biggest problems for, any nation or even a large company trying to build their own AI.
Yeah.
The lack of massive computing power and the need for data privacy.
Got it.
So Nova4j was launched by Amazon Web Services, AWS, at their big reInvent conference in late 2025. And it's all built around their main generative AI model series, which is called Amazon Nova. The whole point is to let customers, and that could be a huge multinational or a government, build their own custom frontier models. AWS has a brand for these. They call them Novellas.
Novella's cute.
Yeah.
So if Amazon Nova is the giant pre-trained base model like the engine block of a car, then the Novellas are the specialized cars built on that chassis, tailored just for one customer.
That's the perfect way to think about it. And the real innovation here is what they call open training.
Open training.
Yeah. I mean, traditionally, if you wanted a world-class large language model, an LLM, you needed two things. First, you had to start from scratch, which could cost billions of dollars and take years.
Wow.
And second, you needed these massive supercomputing clusters. We're talking tens of thousands of high-end GPUs.
And most countries, I mean, outside the US and China, they just don't have that kind of hardware lying around.
Exactly. They don't. So open training gets around that. It lets users inject their own secret proprietary data at different stages of the process.
Like when?
During pre-training, mid-training, or post-training. You basically get to mix your special sauce with AWS's huge, high-quality Nova data set.
So you're leveraging their work.
You're leveraging billions of dollars of their work. The effect is, well, it's democratizing in a way. AWS says it can save customers billions by not having to do that full pre-training run. And, this is key, the final models are hosted securely on AWS, often right inside the customer's own data center.
That drastically lowers the barrier to entry. But let's zoom in on this specific service you mentioned, the mid-training service. You said this is the real shortcut for sovereign AI. Why?
It's the critical phase. Mid-training is specifically for users who have, let's say, mid-sized but really valuable unstructured data.
What's an example of that?
Think of specialized industry knowledge, a company's internal documents, or for a whole country, it could be sensitive government archives, all their legal precedents, or maybe a unique collection of indigenous languages.
Right. Data that's too small to justify a billion-dollar training run on its own.
Exactly, but way too sensitive to just hand over to some foreign black box AI.
Okay, so let's clarify the traditional training structure versus this mid-training advantage. We always hear about pre, mid, and post-training. What's the actual difference?
It's a great question. So the traditional flow is, 1, pre-training. This is the heavy lift. It builds the basic language skills, the reasoning, the basic world knowledge. It's the foundation, and it's the most expensive part.
Okay.
2 is mid-training. This is where you inject domain-specific knowledge. You turn that general foundation into, say, an expert in climate law or aerospace engineering.
And then post-training.
That's just the final polish. Fine-tuning, making sure the model follows instructions perfectly, gets the tone right, and sticks to all the safety rules.
So with Nova Forge's mid-training, what are they doing differently? Why is the timing of when you put the data in so important?
It's all about timing and efficiency. With this service, users step in when the base Nova model is already about 50 to 80% complete.
Oh, so it's already pretty smart.
It's very smart. AWS calls this the learning rate conservative stage. At that point, the foundational knowledge, English grammar, complex math, general world facts, it's already baked in. It's solidified.
Why not just wait until the model's like 95% done and then just throw your data in at the very end?
That's where you run into a huge problem called catastrophic forgetting.
That sounds bad.
It is. If you try to jam in massive amounts of super specialized data too late in the game, say a bunch of niche legal terms that actually conflict with standard English, you risk overwriting the core knowledge the model learned in the first place.
So the model literally forgets how to do basic stuff.
Yes. It forgets how to handle basic language because it's so focused on learning your company's internal jargon.
Wow. That's a fantastic concept. So mid-training is like giving a kid specialized university training right after they finish high school, instead of trying to teach them quantum physics when they're still learning the alphabet.
That's a perfect analogy. The mechanism itself is super technical, but they've streamlined it. The customer downloads an intermediate checkpoint of the Nova model, uses some dedicated AWS hardware like SageMaker or their Trainium chips, and injects their private data for that final stretch of training.
And this midway injection,
it efficiently absorbs all that domain-specific knowledge while, and this is the crucial part, preserving the general abilities the model needs to be intelligent.
The acceleration must be incredible. From years down to what?
Down to just weeks, potentially. And the cost structure is designed to be affordable for this market. Entry costs start around $100,000 a year.
Okay, let's put that cost in context. I mean, $100,000 might sound like a lot for a medium-sized company.
Right.
But for a developing nation that wants to jump over a decade of infrastructure development and get data sovereignty, like tomorrow, that entry fee is a massive political bargain.
That is the entire point. For most of the world, for nations that can't build their own supercomputing clusters, this is the only fast-track solution to get a state-of-the-art national AI model. It's what makes sovereign AI practical.
You brought us right back to the core concept. But I have to ask, if you're using AWS's core model, how can you really say it's sovereign? Let's define that again.
Right, it's a fair question. Sovereign AI means a nation has complete verifiable control over its AI. That means a few things. One, data localization. The data never leaves its borders.
Okay.
Two, it has to comply with local laws like GDPR in Europe or China's data laws. And three, it needs to be deeply integrated with the local culture and language.
So how does Nova Forge deliver that?
Through its integration with something called AWS AI Factories, this lets the customer deploy the final customized model entirely within their own certified data center. So it becomes the most powerful tool available right now to get to that goal, even if it does create, some new dependencies.
Okay, so we've defined the tool, the Nova Forge shortcut. Now let's really get into the motivation. Why has AI become this intense strategic national asset that governments everywhere are scrambling to get their hands on? It's clearly more than just a cool piece of tech.
Well, the whole push for sovereign AI is really driven by some fundamental anxieties. It all stems from the current global tech landscape.
Which is dominated by who?
It's dominated by two things. One, the massive cost of building these frontier models from scratch. And two, the geopolitical rivalry between the US and China. That rivalry forces every other country to either pick a side or try to carve out their own path.
And this gives them a third path.
Exactly. Our analysis shows there are really four core drivers for this scramble.
All right, let's break them down. Let's start with what sounds like the most critical one: data privacy and national security.
This is, for many, an existential issue. The fear is twofold. First, sensitive national data. We're talking military plans, confidential health records, critical economic data could leak or get compromised if it's trained on foreign cloud servers.
Even by accident. But second, and this is more worrying for them, is that the data could become subject to foreign laws.
What do you mean by that?
I mean things like the U.S. Cloud Act. In theory, that allows U.S. government agencies to compel a U.S. company to hand over data they store, no matter where in the world the physical server is.
Whoa, okay, so if a country is relying on a U.S.-based model, their most secret data, even if it's stored on a server in their own capital city, could still be demanded by a foreign government.
That's the fear. So the goal of sovereign AI here is purely defensive. Keep all your strategic data within your own borders under your own laws to prevent spying or the risk that, say, sanctions could cut you off from your own intelligence.
Right.
The EU's big push for a European AI that follows all the GDPR localization rules is probably the best example of this security motivation in action.
It makes sense. If data is your national treasure, you can't let someone else hold the key to the vault. Okay, what's the second driver? Technical independence and economic autonomy. This one goes right back to the compute gap we talked about. Building a foundation LLM takes huge amounts of capital and infrastructure. Those high-end GPUs are often in short supply. They're subject to export controls.
Right.
So countries like India, Brazil, or nations across Southeast Asia, they just don't have the hardware to compete head-to-head. And this leads to a complete technological dependence on U.S. tech giants.
And that dependence means you're paying foreign companies for every single API call, which drains your capital and it kills local innovation.
Precisely. Nova Forge lets them self-produce these high-quality models affordably. And by doing that, they can kickstart their own local AI industries. They create high-skill jobs for their own developers and researchers, and they start bleeding money on foreign tech imports and API fees. It's about building a domestic tech economy, not just, buying a subscription.
Okay, next up is a softer one, but you could argue it's even deeper. Cultural and linguistic adaptation.
Yeah, this goes right back to that local flavor we mentioned at the start. These big universal models are trained mostly on English and Western data. That means they inherently carry cultural and linguistic biases.
And when you deploy them in a totally different environment, those biases can cause real problems.
They can cause dangerous problems. Can you give a concrete example of what that kind of bias might look like?
Absolutely. Think about legal systems. A U.S.-trained model might implicitly get how common law works. But if you deploy that same AI in a country that uses civil law, it might completely misunderstand or even dismiss crucial legal documents because its whole training assumed a Western legal framework.
That's a huge issue.
Or think about healthcare. Local dialects, specific medical terms for regional diseases, historical records written in a niche script. A general English LLM would miss all of that, and that could lead to seriously compromised patient care.
So sovereign AI makes the tool actually useful for your people, not just powerful in a generic way.
Exactly.
Okay, finally, the big picture, geopolitical competition. Right. In this current AI rivalry, you have third countries, especially ones with a lot of money and big ambitions like Saudi Arabia or the UAE. They see sovereign AI as their next strategic asset. It's their digital oil.
Digital oil, I like that.
By controlling their own AI and deploying these localized state-of-the-art models, they boost their diplomatic leverage. They can use a platform like NovaForge as a neutral third option. It lets them get cutting-edge tech without having to fully commit to either the US or the Chinese geopolitical camp.
It's a strategy for staying flexible.
Maximum strategic flexibility.
Okay, so we've got security, economics, culture, and power, all driving this push. But let's apply that critical filter. If NovaForge is selling an 80% finished car, are these nations really getting true autonomy? This is that technical dependency blind spot you mentioned.
And that is the crucial, really complex trade-off. NovaForge is a shortcut, absolutely. But a shortcut always comes with a potential price tag down the line. Meaning, while the customer adds the final 20%, their custom features, their national data, the core design, the underlying architecture, the fundamental engine of that original 80%. That all remains the intellectual property of the original developer, and potentially its vulnerability.
So if there's a security flaw or some kind of deep bias baked into that foundational architecture, something AWS might not even know about, that flaw gets inherited by every single novella built on top of it.
Precisely. And what's more, if the base model's home country, let's say the US, decided to impose sanctions or restrict access to future upgrades of that core, well, the nation's autonomy just evaporates overnight. So what this delivers is a highly customized foreign model, not true, from the ground up self-sovereignty. Real sovereign AI requires independence all the way from research to chip design, and for most nations, that's still just prohibitively expensive.
It sounds less like true sovereignty and more like a high-level tech lease. But you called it a necessary trade-off. Pragmatism versus idealism.
It is pure pragmatism. For a nation that can't spend 10 years and $10 billion to train a model from scratch, NovaForge is the only realistic way to get rapid deployment and local data security. They get immediate control over their data flow and their cultural output. But they have to know that the technical reliance on that 80% core means their long-term goal of complete independence is still a long, long way off. It's a strategic calculation, plain and simple.
Okay, so let's pivot to the balancing act then. Given this dependency, how can a country pursue sovereign control while still getting the benefits of global openness? I mean, if you isolate yourself completely, you just risk developing a mediocre, outdated model, which kind of defeats the whole purpose.
This is the governance challenge of our time.
Yeah.
The conflict is baked in, sovereignty demands autonomy, but rapid AI progress relies entirely on open source communities, on global data sharing, on shared research.
You can't innovate in a vacuum.
You can't. The ITU's AI governance report highlights this perfectly. Many developing nations risk being totally cut off from global innovation if they go for absolute isolation.
So what are the actual mechanisms being used right now to, thread that needle?
Deloitte's work on agile governance points to 5 hybrid strategies. They're all focused on separating the private, sensitive data from the public model intelligence.
Okay, what's the first one?
First, they're using open weight models. So some companies, sometimes with a little government pressure, are releasing open source versions of their model's parameters.
Like OpenAI's GPT OSS.
Exactly. So a nation can download those core intelligence parameters, that's public knowledge, and then locally and privately, they inject their own sensitive data. This lets them innovate quickly while still controlling the final application and making sure it's compliant.
So the world gets the base intelligence, but the nation controls the sensitive part. What's next?
Second is federated learning. This is huge in fields like medical research where privacy is everything. The data stays in situ. It never, ever leaves the local server.
So what gets shared?
Only the learned parameters. The mathematical changes that the local data suggests. That's what gets sent to update the central model. So the central model gets smarter from everybody's knowledge, but the sensitive individual data points stay safe behind local firewalls.
That's a huge security boost. You're sending the recipe, not the raw ingredients.
Third, they use differential privacy. This is a really sophisticated math technique. During training, it deliberately injects a tiny bit of statistical noise into the data sets. It's like blurring a secret document just enough so you can't read the individual words, but you can still see the overall structure.
So you can't reverse engineer specific data points.
Exactly. It protects individual records while keeping the overall trends the model needs to learn. Fourth is split training. This is where you vertically divide the model's architecture.
How does that work?
The foundation, the base layers, are trained externally, maybe using NovaForge. But the super-sensitive top layer, the part that makes the final judgment call on, say, a financial decision or a legal ruling, that module is trained and deployed entirely at home on domestic servers.
So you can keep the final ethical and legal control even if the foundation is foreign.
It's a powerful method. And finally, there's local open sourcing. Countries like Korea or Japan, after building their own highly localized models, are choosing to open source their work.
Why would they do that?
It signals their technical strength, it attracts global feedback to make their model even better, and it helps them stay part of the global innovation scene. So this whole balancing act, buy the foundation, control the input, and selectively share the output, that's the future of how sovereign AI is actually going to be deployed.
We spent a lot of time on the digital brain of AI. Let's bring this conversation down to earth, to the physical body and how it's being deployed. We're talking about the shift from manipulating pixels to controlling actual motors. So let's pivot to the rise of the Chinese robot army and the huge economic and social fallout inside China.
This transition is so important because it shows that AI sovereignty is ultimately about controlling production. And China is facing what you could call a perfect storm that is speeding up robot deployment at a rate we've never seen before.
A perfect storm driven by what?
By both overwhelming demand on one side and some really powerful supply-side advantages on the other.
Okay, let's start with the demand side, the labor crisis. Just how bad is this demographic cliff that's forcing them to rush into automation?
The demographic situation is the absolute core driver. China's population has shrunk for 2 years in a row now, but the critical number for manufacturing is the working age population, people aged 16 to 59, and that is shrinking fast.
So the traditional, endless supply of cheap factory labor is just drying up.
It's completely drying up. This creates a massive labor vacuum. Those high-intensity, low-wage factory jobs are becoming really unattractive to the younger, more educated generations. Projections show a labor gap of around 11.8 million workers a year by 2030, just in manufacturing.
Wow.
So you have companies like Foxconn, a giant in the industry, rapidly deploying robots just to fill their quotas and keep the production lines moving. Robots are going from a nice-to-have upgrade to a total survival necessity.
They need them just to keep up, so that's the demand. Now, what about the supply side? Mechatronics mastery. Where did China get so good at building robots?
This is a story of smart policy and technological spillover. China now has world-leading capabilities in all the core robot components. And they didn't get there by just focusing on robotics. They got there through massive state-subsidized investment in related high-tech fields, specifically electric vehicles and consumer drones.
Okay, how do EVs and drones make you good at building robots?
Because they force you to master the key mechanical parts of physical AI. Advanced electric motors, precision gearboxes, what they call reducers, and super reliable electronic controllers. By becoming the one leader in EV batteries, motors, and drone parts, China accidentally built the perfect domestic supply chain to produce millions of standardized, high-quality, and cheap robot components.
It's horizontal integration. They're applying automotive-level quality control to factory automation.
That's exactly it. And this is all backed by strong policy. The Made in China 2025 plan has poured over 500 billion RMB into this sector. And they have an aggressive goal, 500 robots for every 10,000 workers. That density would be among the highest in the world.
So they have the motive, the labor shortage, and the means, the components, and the policy.
It's a perfect storm.
Okay, so here's where it gets complicated for me. This is the intellectual friction point. If there is this massive looming labor shortage, why is youth unemployment in China so alarmingly high? We're hearing numbers up to 20% in 2025. How do you square that circle? The core contradiction, shortage versus mass unemployment.
This is the labor market paradox, and it's the central structural pain point of China's whole economic transition. The analysis in the RAND report helps break this down into 3 key, really distinct problems.
Okay, what's number one?
Number 1, skills mismatch. The critical shortage is not for general laborers, it's for high-skill workers. They need AI engineers, robot technicians, maintenance specialists who can diagnose a complex automation failure, data scientists.
Right.
They need an estimated 62 million of these specialized workers. The unemployed population, on the other hand, is mostly low-skill workers or university graduates with a general education, but without the specific technical certifications you need on a modern, automated factory floor.
So the factory needs a brain surgeon, but the job market is full of people trained to hand out aspirin. The supply and demand are totally misaligned by skill.
That is the perfect description. Okay, number 2, Technological displacement. Robots are doing more than just filling empty spots. They are structurally replacing labor in roles that are still currently filled by people.
How many roles are we talking about?
The analysis suggests up to 54% of current low-skill manufacturing jobs are at risk. That's a mind-boggling figure that could affect 123 million jobs.
123 million. That scale is terrifying.
It's a critical societal shock, and this displacement is structural, it's immediate, and it's happening faster than any government can possibly roll out retraining programs.
Okay, what's the third piece of the paradox?
It's a societal shift. Automation is basically enabling younger generations to just refuse to do that kind of high-intensity, physically demanding factory work. They have better education, they want service jobs, they want to be in the gig economy, they want white-collar roles.
And the robots make that escape possible.
Exactly. Automation provides the technical foundation that allows this escape from traditional manufacturing to happen faster, which in turn forces factories to automate even more, rather than trying to rely on a future generation of human labor that just isn't coming.
So automation isn't just a solution to a problem. It's a catalyst that's making the low-skilled workforce obsolete even faster. It's widening the skills gap and making regional economic inequality worse.
That's it. The robot army is a huge strategic win for the nation, but it creates this massive concentrated social cost for the people.
And that contradiction, this machine of productivity creating so much social distress, that sets up our final, really high-stakes debate. Does the success of this robot army pose a bigger risk to the outside world or to China itself? This is really the heart of the issue, isn't it? We have this incredibly rapid, successful rollout of automation in China. Is this something the rest of the world needs to worry about and manage? Or is it an internal social time bomb that China should be more worried about? Let's take the external view first.
Yeah, let's start with perspective one, why the world should worry. The core fear from the global perspective, especially from the US and the EU, is actually pretty simple. It's that China becomes too efficient, that it dominates global supply chains to a point where it's irreversible, and that it produces goods so cheaply that it completely distorts international markets.
Let's start with the most immediate economic threat there, overcapacity and dumping.
Right. AI-driven efficiency just maximizes production capacity. When you combine that massive scale, state subsidies, and tireless machine labor, it means Chinese manufacturing can just churn out products.
Especially in those strategic industries.
Exactly, like EVs, steel, solar panels at prices that are just unsustainably low for anyone else. This ability to flood global markets is what triggers trade protests and accusations of dumping. I mean, the Financial Times, EU trade bodies, they've all explicitly warned that this massive robot deployment will cement China's manufacturing dominance and make fair competition almost impossible.
Western countries are already having a hard time competing with subsidized labor. Competing with subsidized robots is a whole different ballgame.
It's a completely different level. And this leads directly to the second point. Irreversible supply chain dominance. The US and the EU have spent billions trying to what they call de-risk.
Which is the strategy of diversifying critical supply chains, everything from medicine to computer chips, away from being so dependent on one country, specifically China.
Exactly. But if China fully automates, doesn't that make those supply chains more resilient and actually harder to move away from?
It does. The increased machine integration and the sheer efficiency from this robot army actually makes global supply chains more dependent on China, at least in the short to medium term.
Right.
The cost, the speed, the reliability you get from advanced automation, you can't just replicate that somewhere else overnight. It frustrates all of those de-risking efforts. They become too efficient to functionally replace, so they're becoming technologically indispensable, even as countries are trying to pull away politically.
And the final external worry is the classic dual-use military technology risk. All that civilian robot innovation, the advanced sensors, the general-purpose humanoid robots, the control algorithms developed for warehouses and factories.
It translates directly to military capabilities.
Rapidly. We're talking autonomous logistics, rapid assembly of military hardware, battlefield maintenance using AI-controlled robots. It poses a huge long-term strategic threat, and it's a concern that U.S. defense think tanks raise all the time. The line between a civilian factory robot and a military logistics bot is getting very, very blurry.
So externally, the fear is about market distortion, inescapable dependency, and a shift in strategic power. Now let's flip it.
Let's flip it perspective two, why China should worry more.
The core fear here, internally, is that the very success of the technology leads to a catastrophic social failure, to domestic instability. This is about what happens when a technological revolution makes hundreds of millions of people obsolete, structurally.
And this internal risk is so much more acute because the system just isn't equipped to handle it. Let's start with the sheer scale of the structural unemployment crisis.
Right.
We are talking about the mass replacement of the migrant worker population and older factory employees. These are people who have relied on physical labor for decades and who just don't have the capacity or the resources for any kind of meaningful retraining.
If that entire source of labor vanishes, what replaces the income for those families?
Under the current system, nothing sufficient. The International Labor Organization, the ILO, has issued some really grave warnings about this. They say the social cost of this technical unemployment in China will be far higher than in developed countries.
Why?
Because the state's social safety net unemployment benefits, pensions, social housing, it's rudimentary, it's fragmented by region, and it's completely unprepared for a shock of this size. Millions of people suddenly needing comprehensive support will just overwhelm the system.
And it's not just blue-collar workers, right? We also have to think about youth disillusionment.
Absolutely. AI is moving up the cognitive ladder fast. It's replacing entry-level white-collar jobs, basic legal research, customer support.
All the jobs new graduates would normally take.
All of them. This displacement hits millions of newly educated college graduates, which makes the already high youth unemployment rates even worse. This fuels a lot of social discontent, and it accelerates things like the lying flat phenomenon, where young people just choose to opt out of this super competitive, rapidly automating job market.
So automation is kicking away the bottom rungs of the career ladder, just as millions of educated young people are trying to get on it.
And this leads critically to wealth concentration and social strain. The profits from automation, they flow overwhelmingly to the people who own the capital, the tech executives, the big industrialists. Meanwhile, the massive social cost funding, unemployment, poverty relief, retraining that's borne by the state and by the masses.
This just accelerates inequality.
Massively. When technology guarantees immense wealth for a tiny few but insecurity for the many, you have a recipe for volatility.
Which brings us to the ultimate danger for the central government, the threat to stability. When you have millions of displaced workers who don't have adequate ways to get help or comprehensive state support, and that dissatisfaction just builds and builds, that becomes highly combustible.
Social stability is the government's #1 priority. When the economy was growing at 8% a year, they could absorb technological displacement. But when the economy slows down at the same time that technology is accelerating job loss, you create this critical mass of discontent that poses the single greatest threat to the existing social contract.
So the robot success is directly undermining the state's own internal legitimacy.
Unless massive reforms happen, yes.
Okay, so we've got global economic shock on one side and domestic social implosion on the other. What's the final judgment here? Where's the bigger risk?
Well, if you look at the nature of the risks, the world's risk is, I would say, gradual and controllable. Global trade partners can respond. They have tools like tariffs, industrial subsidies, trade sanctions. They can manage the economic shock over time.
But China's internal risk?
China's internal risk is internal combustion. It's explosive, and it's profoundly disruptive to its political stability and social fabric.
So the robots are successfully solving a problem for the state, the labor shortage. But at the same time, they're creating an existential crisis for the people, the job shortage.
That is the core paradox. And for that reason, my final judgment is that China itself is the party that should be most concerned. The rapid success of this technology is magnifying these deep structural societal conflicts that have been brewing for years.
And without a massive response.
Without massive government-led, unprecedented retraining programs and proactive wealth redistribution to share the benefits of automation, the robot revolution's technological success will inevitably be paid for by catastrophic social instability.
Which means this whole conversation about AI and robotics has to move beyond just the tech. It has to start addressing these profound issues of social ethics and distributive justice.
The technology doesn't exist in a vacuum. Its political consequences are what really matter in the end.
We've established that sovereign AI secures the digital brain, and robotics is the strong body that executes its will. Now let's connect those two themes, data control and physical production, and look at the future convergence. What are the major shifts we can expect to see by 2026? This is where the national strategy really hits the factory floor.
The fusion is happening right now. Nations want control over their critical supply chains, and to do that, you have to control the underlying intelligence, the AI that runs the factories and the logistics networks. It's about securing physical production.
Okay, so how does that technical integration actually work on the factory floor? Does that Nova Forge mid-training service play a role in making a robot sovereign?
Oh, it absolutely does. The key is an edge AI local on-device computing. Mid-training lets a country inject its highly localized, sensitive operational codes, things like unique factory layouts, specific safety protocols, or regional machinery maintenance schedules, directly into the robot's control model.
And that model is deployed where?
Right on the robot itself, at the edge of the network. This ensures the robot's decision-making is local, it's fast, and it's compliant with all local laws and privacy rules, like GDPR. The robot doesn't need to constantly send sensitive operational data back to a foreign cloud to figure out what to do. The customized sovereign model is already baked right in.
That makes the robot a secure, locally intelligent asset. Can you give us some current examples of this strategy in action?
Sure. In China, the strategic priority is to fill that labor gap immediately. So humanoid robots, the Optimus-style models that are designed to mimic human motion and adapt to messy factory environments, they're being trained with powerful local models like Baidu Ernie. It's a direct government-backed push to get flexible machine labor into manufacturing as fast as possible.
And other places like Taiwan are taking a different approach, right? Focusing on components, not just scale.
Precisely. Taiwan is playing to its strengths in semiconductors and AI. They're making a massive investment, 190 billion TWD, to become a critical robotics supply chain hub. They're focusing on integrating their own sovereign models into collaborative robotic arms cobots made by companies like Deckman Robot.
So they want to control the specialized components and the local intelligence that powers precision manufacturing, not necessarily the large-scale assembly lines.
That's their niche. So whether a nation is going for massive scale to fill a labor gap or specialized precision to dominate a component market, AI sovereignty controlling the data and the model is the engine that's driving all of this physical automation. The convergence makes the whole AI project holistic. It's about data security and physical production security.
Let's look forward now. Instead of just listing off 10 superficial trends, let's focus on maybe the 3 or 4 most critical, transformative trends from reports by places like TrendForce and connect them directly back to our themes of sovereignty and labor displacement.
Okay, this is where we synthesize everything we've talked about.
The first critical trend we have to understand is agentic AI.
This is probably the biggest near-term shift. Agentic AI is moving beyond just generating responses like current LLMs do. It's starting to autonomously plan goals, break them down into smaller tasks, and solve complex problems without constant human oversight. Think of it as upgrading a tool into a managerial employee.
And how does that connect back to the paradox we were discussing in China?
Well, if current automation replaces 54% of low-skill manufacturing jobs, agentic AI, which can manage supply chains or run entire back-office functions, it starts to accelerate white-collar and middle management displacement.
Oh, wow.
We're predicting a 50% increase in enterprise automation just because the AI can now manage its own workflow. This is going to seriously heighten that youth disillusionment and structural unemployment we talked about. The problem isn't just low-skill job loss anymore, it's cognitive labor being automated at a managerial level.
The second trend is, naturally, physical AI and world models.
This is the robot army becoming a reality. Physical AI is AI that can interact flawlessly with the real messy world, from a hospital operating room to a construction site. And this is all powered by something called World Models AI that can simulate virtual and real-world interactions millions of times before it ever takes a physical action.
Why is that so important for national strategy?
Speed and reliability. It used to take months of physical trial and error to develop a complex manufacturing robot. With world models, a country can deploy sovereign models that have already practiced a task millions of times in a simulation. That means much faster deployment, much higher reliability, and huge cost savings.
And the numbers back this up.
They do. The prediction of a $38 billion market for humanoid robots and 50,000 units shipping in 2026 just confirms this is moving from a novelty to a necessity for national production. And sovereign control over these models is what ensures that critical physical infrastructure stays secure.
The third trend, then, has to be the necessary countermeasure to all this speed and power: responsible AI and quantum security.
Exactly. As the tech capability just explodes, the need for strong governance becomes absolutely critical. The EU AI Act is forcing a global increase in regulatory compliance. This means these sovereign AI frameworks have to demand verifiable decision-making, transparency, and auditability. If a robot trained on a novella model fails, the nation has to be able to know why without waiting for a foreign company to do an audit.
And where does quantum security fit into this?
It's a foundational requirement for any long-term sovereignty. If a quantum computer can break our current encryption standards, then all that sensitive sovereign AI, data national secrets, protected medical records, infrastructure plans, it could all become instantly vulnerable. So a rapid investment in post-quantum cryptography becomes an essential part of the 2026 national security strategy.
What's so fascinating about these trends is that they all just confirm the premise of our entire conversation today. AI is going to become even more politicized and nationalized. It's driving innovation and competition globally, while at the same time creating these profound internal social risks.
The scale of the change is what you have to grasp. We're not talking about gradual updates. We're talking about a fundamental restructuring of global power and domestic economies, all happening within the next 24 months. Sip&Talkers, we've come full circle in this intense deep dive. Today was all about the control and the consequence of AI power. Sovereign AI is the necessary strategy for nations to secure the smart brain, the digital model, and robotics is the strategic method they use to deploy the strong body, the manufacturing force.
And this massive global push, driven by the need to fill labor gaps and gain geopolitical leverage, is going to drive immense productivity jumps globally. We're talking about restructuring economies and maybe even achieving 10x the global output in some sectors. But, as we emphasized, it fundamentally redefines the human job market. The core conflict is that a technical solution for the nation, like the Novo4 shortcut, creates a massive disruptive social problem for its people, like structural accelerating unemployment.
We always strive to maintain an objective, international perspective on these complex issues. We've simply reported on the factual impact of these technologies as they are being implemented, emphasizing that these are strategic calculations being made by governments across the globe. We aren't financial experts, and any industry examples we used are strictly for reference and discussion.
And as we conclude, here is our final provocative thought for you to chew on. This is the real cost that must be monitored. We've discussed the immense cost and effort required to build this advanced AI infrastructure. But the greatest cost, and the one we must all watch, will be the cost of not reforming society fast enough to accommodate the millions of workers structurally displaced by these advanced national strategies. Is AI's future going to be one of rapidly shared prosperity and leisure? Or is the sovereign control of technology simply guaranteeing wealth and stability for the technological elite, leaving the masses behind?
Think about that. The technological answer seems clear, but the social contract is still pending.
Make sure to subscribe to the Sip&Talk podcast. And check out our old friend Mickey's YouTube channel, Mickeytolife, for some fun memes and his latest travel vlogs. We'll catch you next time.